And welcome guys to a small little example that I'm going to do for types. And I think that's what I'm going to call it, is probably types in the title. Now, and a lot of times we need lists and stuff like that, but you know, we may need more than one type. And a lot of times we don't want to make more than one list. We just want to deal with whatever it is that we're working with. Well, I have these classes here: base type, building type, then just unit, object. Now these could all be like different types of things, like a building unit versus a unit object. Well, I want a list of these, and they basically have the same functionality. Like a building, I want to know the position of the building. Okay, I also want to know the position of the unit as well. And you could do some type of drive type and everything and be like, well, both these are inherent from whatever, but let's say hypothetically, well, the unit type, I need it to call a certain function like right off the bat when I like attack or update or do this. And then on the building, I need it to, hey, what I want the position and call a completely different function inside a building. Now we can do some type of overriding and things like that, but wouldn't it be nice just to be able to tell what type of script it is and then call the functions inside that script that you actually need it to do? Well, there is a way that you can do it. I'm going to show you a way where you can cast it to a type of, basically force it to just do what it needs to do. And it's pretty dynamic for what you need. Okay, sometimes, because when you do let's say healing potion or something of that nature, you need to know what type of type it is. So in my little start here, I've got two scripts: a building script and a unit script. I also have this log. Hey, we're attacking your building. That's a unit. We've got an ID, okay, and attacking your base, okay. These all are different scripts, and they get instantiated at runtime, but they all are called from a list. We have one list that does all this. Now I can basically have more of these if I really wanted to, and drag them in, and notice how I put this number here, it matches this number. Okay, we basically, why don't I get the ID of the unit as well? Doesn't matter. So how do I do this? Well, you have to do a little bit of inheritance, but it's not too bad. Just a step, okay? And I used an enum for the type, okay? In C#, there's a gettype function that you can use, and it returns the type of the script and stuff. But then you got to inside your script write what it is and things like that. And I just didn't want to explain that whole convoluted thing anyway. So what I did instead was I used an enum. Okay, a very easy enum, because here's a few reasons why. If you do an enum like this, okay, and you want to make a switch statement like this. Now, instead of typing all this crap out with different cases and all that good stuff, you can come down here in your function, okay, and you can hit switch, okay. Now, if you're in Visual Studio, and I believe MonoDevelop also does it too, hit it twice, Okay, now the switch on, you have to give it a type, which I'm going to give it cast type, and then go down. Okay, so I just gave it a type. It's an invalid expression because this isn't actually a variable yet, but it gave me all the cases for it. Okay, so in my function, I would do a cast type t equals cast type top building, maybe. And the switch, I would put t in here because we're, basically calling up a function, and then it returns, hey, what case are you doing? What are you doing? Okay, so it typed all this crap for me, so I don't have to, do this junk. Okay, I don't have to worry about my spelling or anything like that, and it makes it really easy to type out the function the way you need. Now, the way to do it is we need something in the scene. So I just added it to the list, and I called it from base objects. Everything from the building to the units comes from base object. And all this does is take a virtual function of cast type, and we override this return method here. Okay? So in our unit class and things, I would override this, the cast type, and say this is a unit for the unit object. Okay, so the unit object is all, hunky-dory. Well, now I've got the building object, okay, and I just have a return building. Very, very easy. So in the list, we have our base object. Okay, now the stuff that I add to the list, it's instantiated in the background, in memory and stuff. What casting it like this does is it tells you the C# and Unity, or however you want to interpret it, to force it to be read this way. In memory, it's in memory this type, but when we go up to here in the object, our base class, it's holding a reference to it, but we only have access to the base version right now. If it's instantiated into the memory as a build object, we can call up a function build object.I cast type. This returns the enum nothing, unit, building, whatever it actually is that we're overriding in the class right here. It reads it, okay? It pulls out the object, goes, hey, what type are you? And then it goes down here to the case. Are you nothing? Are you a unit, building, a turret? And we grab a variable, just make a variable. Then we're going, hey, force object I to be this. I know what you are. Now I want C# to read you something different than an object, a base object. I want you to be read as a unit. I know you're a unit. Give me access to all your functions and everything for a unit. Now, there is some drawbacks to this. When you're casting a type like this and everything else, it fiddles with the memory, a little bit of allocation and stuff, because you're going, hey, do this. You're actually I think it's part of reflections, but don't quote me on that. But it does have its drawbacks. It is, don't do something like this every single frame, because it's just like remember how we used to do float I equals 50.111F. And then, what? Why do you have a problem with that? It's not a string. Oh, because you already exist. Floats, nums. Okay. Well, nums, you know, we got this floating point thing here. And a lot of times, you really don't want this to be a floating point problem. So a lot of times what we'll do is, to get rid of it, we'll go, hey, we'll just have you forced to be an integer. So now it's being treated as an integer. Okay? But what we love to do a lot of times as well is we'll go down here and we'll go int amount, okay? And we need this to be an amount which was equal to nums. Well, this is an invalid right now. We want this number to come from a floating, but a lot of times you have issues. Like, let's say vector3.1, we only want the rounded off number. So what we do is we just force it to be an integer, or we do a mathf dot floor to int, okay, and that will give us an integer as well. But you know, to be honest with you, what I would probably have done anyway, not this mathf thing, is just go, hey, guess what, treat it as an integer, int. And the reason why I would do it that way is simple. C#'s been around for ages and ages and ages, or whatever, however long you think. Going the C# way, forcing it into an int, is probably just as optimized as doing a mathf floor to int. And two, mathf, that function and everything else, I believe that's part of Unity's version of it anyway. Which in the background, I bet it's doing exactly the same thing. Which, you know, is kind of silly. Because this is part of system, and I believe mathf is not, yeah, it's part of their thing. It's just an easier way of doing the same thing. But anyway, that's how that works. Now, if you're thinking, well, this unit right here, the case study, I could still mess this up. There's nothing in here that says I can't go and go build type, guess what, build type, and then have the wrong functions. Okay? You could still mess it up like that. Okay? But this is pretty flexible, especially if you're dealing with a bunch of objects that you want to save. And each one of those objects save differently. You got different functions for each one, or different variables. You know, when you're going into a save file, you know, you pretty much have to go, hey, we need different types, but at the same time, each gun has the same crap that we've got to know, or the same UI stuff. Hey, this is a UI element. save it in this stuff, do this, do this, do this, but we still want to use only one collection, which is really nice because, hey, when it comes to base objects, it's nice to be able to stuff it in one single list instead of having 3 or 4 different lists. And then you gotta write a function, hey, iterate through this one, iterate through that one. Kind of meh. Okay? Meh. But I thought that I would bring this up because it's pretty flexible for items. We're going to deal with it a little bit in our FPS that we have going on, because buttons have became more of a headache to work with in certain parts of the program versus others. And I'd much rather cast it to a type than to find some convoluted way of, separating different types, because it's kind of dumb. But hopefully you find this useful, and please remember to like, hit subscribe, and take care. But this is definitely war over and out. Peace out, everybody, and hope you make some good stuff and good games. But peace out.